Okay.
Introduce Professor Nizar Habash from NYU Abu Dhabi. Professor Habash is also the director of the Computational Approach to Modeling Language Lab in NYU Abu Dhabi. He specializes in natural language processing and computational linguistics. Before joining NYU Abu Dhabi in 2014, he was a research scientist at the Columbia University's Center for Computational Learning System. He received his PhD in computer science from the University of Maryland, College Park in 2003. He has 2 bachelor degrees, one in computer engineering, the other one in linguistics and language, which are both essential for NLP. And his research includes extensive work on machine translation, morphological analysis, and computational modeling of Arabic and its dialectics. Professor Habash has been a principal investigator and co-investigator over 25 research grants. He has also over 200 publications, including a book titled Introduction to Arabic Natural Language Processing. Without further ado, let's just welcome Professor Habash for his talk on Arabic and artificial intelligence. Thank you.
Thank you very much, Professor Song, and thank you everybody at MBZUAI for inviting me. I hope this will be an enjoyable and talk, and you'll learn something maybe different than you are experts in your area, of course, of AI. So I feel that I'm among, colleagues, but I hope I will be able to share some of my views of the world when it comes to natural language processing in Arabic particularly. The talk is structured as follows. I'm going to first just do a quick kind of synchronization of terminology, talk about language and AI in general, and this is really for the benefits of the students who may be maybe not as familiar with NLP and AI for language. And then I'll talk about Arabic AI challenges specifically, and then talk about a brief history of work on Arabic AI. Some of the earliest efforts actually started in the 1980s, if you're surprised. And then I will talk, in shameless advertising for my lab and some of the work that we do as an example of the this current stage that we're in Arabic and artificial intelligence. All my slides are in Arabic and English, and that's something I started doing for the purpose of helping educate more Arabs about NLP and help kind of smooth it in for them. So when we talk about artificial intelligence, it's a very broad umbrella term, of course, that involves lots and lots of different areas. Obviously, vision, one that you guys specialize in quite heavily. Natural language processing, otherwise called computational linguistics, and sometimes language technologies, are basically the space within AI where we deal with human languages. Either when we search for them, we translate them, we use them as an interface with robotic agents of different kinds, or we do analysis of images, etc. So you're all familiar with a lot of these ideas. This is a field that is quite interdisciplinary. As was pointed out, my background in engineering and in linguistics actually helped me a lot. It got me started exactly in what I wanted to do. What I wanted to do was work on Arabic NLP at age 19, basically. I discovered that, and I thought that was a field that I fell in love with. I wanted to work on. And this field, of course, is one of the earliest ones that have been worked on within computer science in general. And beyond AI in itself, kind of for producing, smart predictive systems, there's a lot of areas now that depend on the good quality results that we produce, that look at it from the point of view of humanities, using our tools to study their own questions. So there's always really interesting connections, and this only happens because of the quality overall improving over time, particularly in the last decade or so with the increase in machine learning successes. When I talk here, I will be mentioning the word enabling technology sometimes, and I want to distinguish it from applications. So applications, we typically think of them as kind of a black box system with a very clear user interface for an input and output. For example, translation, as a good example, you put in text in Chinese, you get text back in Arabic. Very clear as an application. You could use any number of different techniques within them. But enabling technologies is another space where we actually go and develop components with a particular way of improving them so that they can be used within these applications. I acknowledge here, obviously, there's a lot of interest often in the elegance of single joint models that are single boxes with multiple layers embedded as a single model. But we found that actually often the limitation comes from the lack of resources to train. You don't have enough training data. And in the case of Arabic, this becomes even more complex. And I will talk about that. Hopefully it will be clear by the time I am done with this talk. But to give you just a taste of what's coming, what you see here is a single word in Arabic, وَسَيَكْتُبُونَهَا, and it translates into "and they will write it" in English. And we can think of ways of tokenizing or segmenting these words into smaller units so that they can be easily learnable and mappable, and then we reduce the out of vocabulary within our systems. There are lots of techniques, of course, that do tokenization today, like using word pieces, BPE, etc. But we found that even using these, if you actually have something that is more linguistically aware, it actually helps improve the quality of the process as a whole. And again, I hope this will be clear by the time I'm done with the discussion of the challenges. In terms of the techniques that are used, obviously today we live in the machine learning era where there is rules, so to speak, are kind of learned from examples, and deep learning has made a huge change, and we use deep learning heavily within our work. But at times we also find that we need to use some basic rule-based approaches for some things, particularly when there are no resources that are available, or how to create initial resources and include the humans in doing the annotations. So while machine learning is great, and it's actually the way we're all going, we have to also be sensible at times to kind of make use of what we need. And what is it that we'll need? We'll need lots of data, and primarily annotated data. So if you're doing translation, you would need parallel data between the languages that you're translating from. If you're doing sentiment analysis, you need examples of the things that you want to do analysis on with the sentiment associated, and so on and so forth. And of course, the more data, the better. And but we also have to be conscious that you cannot just simply say any particular language is rich in resources. It's the specific genres of it that are actually rich in those particular resources. So English may be rich in general, for example, compared to Arabic, but there are certain areas of working on English where we don't have necessarily as much resources as other, like, let's say, think of literary text, for example. And these models particularly become, models that are trained in a particular way. So if you train on news text primarily, and you try then to apply it to tweets or poetry or etc., you're going to have some problems, of course. This is, of course, independent of the quality of the annotations, which are extremely important. And it kind of makes me think of this cute little baby learning, because machine learning and human learning at some level, from a black box point of view, are kind of, we can think of them as similar, except that babies seem to be a lot better at actually learning language than machines are, even with all of the neural modeling metaphors that we keep throwing around. As an example, today you have excellent machine translation systems that are not yet perfectly at the human level of production, but that need hundreds of millions of sentences to train on. Humans don't actually need to read 100 million of sentences before they can learn how to translate. So it's something there that we kind of have to be conscious of, and potentially try to think of better ways of doing this and exploiting it. So algorithms are then extremely important in helping us actually bridge that gap and developing better systems. And within the work that I do, I often actually rely on, at times, on linguistic and intuitions, and do pairings in the design of the features that I use within machine learning, of how to actually develop systems that can do better using those additional insights. So this is just kind of to give you a sense of where I'm coming from, coming toward NLP and language processing in general. Now we'll talk about Arabic, and I'm assuming here people don't know any Arabic, so bear with me. The main challenges fall into these set of scary looking items, So it's a language that has a high degree of ambiguity and a high degree of richness. It has a lot of dialects, and there's a lot of inconsistency in the way people write it. This is beside the typical thing that you would have from many other languages, like limited resources and tools, and also limited research. It's not necessarily that a language, Arabic is not the only one with ambiguity, and it's not the only one with richness, and it's the only one with dialects, but these seem to be kind of a perfect storm of combination of different elements that make the problem particularly hard. So Arabic, if you know nothing about Arabic, first thing you should know, Arabic is written from right to left, and it has components or letters that are basically connected with each other. And this used to actually be an interesting problem about 20, 30 years ago when people would worry about actually implementing. I was part actually of a startup almost 20 years ago that tries to kind of find a solution to support this kind of work. Of course, this became obsolete very quickly with Unicode and support for Unicode being so universal. I will not be talking about anything related to this. Just wanted to kind of just say that I acknowledge this is actually an interesting problem, particularly for people interested in OCR, etc. But for us, I usually, most of the work that I do starts with texts that have already been kind of represented properly in memory. So assuming we have that, we have the first problem is called orthographic ambiguity. And orthographic ambiguity is about the fact that Arabic, the way it's written, it does not use, or it has optional diacritical marks. And these are basically short vowels that lead to different pronunciations, but we just don't write them. Children learn them first, like first, second grade. And also when you read the holy text, for example, in the Quran, you're supposed to read it with the full diacritization so you don't make mistakes pronouncing the holy text. But most newspapers, for example, do not have these diacritical marks. And you can see this example below. You have this word, and it has, these are 4 different variations of the word with just different symbols on top and below that tell you how to pronounce it. So this would be وَبِعُقَدِنَا وَبِعَقْدِنَا وَبِعَقْدِنَا وَبِعَقِدْنَا or بِعَقِدْنَا. This is a dialectal reading in this last one. In the standard text that you would find in the news, 1.5% of the words has a diacritic on it, not necessarily in the right place, by the way. It should be somewhere on the word, because people figure it out from context. So reading Arabic has been criticized at times that it's a really kind of a highly high disambiguation requirement task. Standard Arabic words have about 7 readings on average as a result of this, out of context. And in context, of course, most people figure out how to read them, who know the language, of course. Second aspect is morphological richness, and this is different. So this is not saying that a particular word has multiple readings, but rather that a particular word has multiple forms that would appear in different contexts. So think of this here of the English verb to say, for example, would appear as say, S-A-Y, or said, or says, or saying, for example. In Arabic, in principle, this number can get to 5,400. And that's because of all the different things that we can attach to the form of the word. So we have particles, what's called clitics, pronouns, first the subject pronoun, and then the direct object pronoun, and in some of the dialect, the indirect object pronoun can all basically attach to the form. It's not as bad as Turkish can get, you know, which is highly agglutinative, but it's on its way there within a controlled space. And of course, you know, English has about 6 maximum, and Chinese wins the game with 1 form of verb basically for every verb. Third problem is dialectal variation. So when we talk about Arabic, you're talking about, you know, about 1,400 years of recorded Arabic. Obviously, we believe Arabic is a bit longer, has a longer life before that, but the earliest record of it that is started just before the beginning of Islam. And it really got a lot of its power kind of and standards were because of the religion of Islam. So classical Arabic is the earlier form of it. This is an interesting kind of thing that Arabs today who learn standard Arabic can technically read classical Arabic, read it. Now, not necessarily always understand all the words. About 10% of the words are actually quite hard to read. And they may have other meanings, but for the most part, we're able to read it. So it's not the same as the experience, for example, of English speaker with Old English, which is completely unreadable for them. They cannot figure anything out from it. And this is something that Arabs very much cherish, and it's part of our basic big heritage here. So we have classical Arabic. We have also standard or modern standard Arabic, which is the official language that is used in the news and the media. And it's considered the language of the nation or the national language, but it is actually not the native language of everyday speech. So children at home learn a different kind of language called Dialectal Arabic, and it's quite different at times from the standard Arabic, to the point that in like Tunisian Arabic, there was a study that showed about 60% of the vocabulary the children know at home, they have to learn new words for when they go to school and learn to speak in standard Arabic, plus differences in the grammar and a lot of other things that come. In the past, people used to say that dialectal Arabic is primarily spoken, not interesting for text processing purposes. This has changed quite a lot, actually, over the last 10 or so years, particularly with the success of social media sites. People now write on Facebook and on Twitter a lot more than they, write. They write in the dialect a lot more than they write in standard Arabic. And this has actually kind of motivated a lot of current research in the dialect as a result. So when we talk about Arabic dialects, they're not divided by countries. There's actually regions of dialects that actually are separate from the borders of the countries, because the borders of the Arab countries were all created by colonial powers at the beginning of the last century, and they were not actually paying attention to how people speak necessarily. The general classification at a high level talks about things like Gulf Arabic, the one that's spoken in the area we're in here, Levantine Arabic, Egyptian Arabic, and Maghrebi Arabic. And then there are also lots of different variations within every particular region. So it's not that everybody, let's say, in Levantine speaks exactly the same way. There are many different variations within them. And across all of this, what's really interesting is that the standard Arabic and the dialectal Arabic basically go hand in hand. It's what's called diaglossia, or linguistic duality. So an educated Arabic person today, let's say from Abu Dhabi, would be able to speak at home in Gulf Arabic. And then if they have a job, let's say a government job or a position where they have to use standard Arabic, they have to be able to switch to standard Arabic and know exactly when to switch between one form and the other. And often people in the speech, they would switch between the two. And on top of it, sometimes introduce English in the middle of the speech too. So you get lots of different linguistic kind of alternations and code switching that make this quite an interesting problem to deal with. For Arabs, the question of, is this a dialect or a language? So I'm talking to the non-Arabs, it's an intense political question because it has a lot of implications about Arab identity, etc. I kind of take the attitude as a technologist that the question is really not as important from a technology point of view. What's important is developing tools that actually serve a purpose, regardless of how people speak or how they decide they want to speak. And maybe we know that these dialects and the standard are related to each other. Can we exploit some of its relatedness to help us build better systems, right? Now, some of the differences, just to kind of give you a sense of the degree of variations, because sometimes people say, oh, is this like British and American, and it's not like British and American. It's a lot more complex than British and American. So there are some aspects like phonological aspects, where one particular sound, like the qaf sound, for example, could be pronounced in 5 different ways, depending on the dialect that you're in. So you get to this example, this word, qalb, which means heart, could be pronounced qalb, galb, or elb, depending on where you are. Also, this also leads to other weird kind of results where a word like fajr could actually mean 2 things, depending on where you are. So it's same pronunciation, but it's actually would be spelled potentially in 2 different ways because it means 2 different things historically. So that adds to this kind of confusion. In terms of the morphology, morphology means the structure of the word, like what elements go within the word. One of the first things that people observe kind of positively is that dialectal Arabic simplified a lot of the complex rules of standard Arabic. So standard Arabic has multiple case endings, so different forms of the word that tell you whether you are at the where you are the subject or the object or the direct object of a preposition, and all of this is pretty much gone in almost all Arabic dialects. But then Arabic dialects add a bunch of other what's called clitics, or these connective particles. So you could end up with a word like the one at the bottom, which is from Egyptian Arabic, meaning, and you all did not write it for him as a single word. وَمَكْتَبْتُ هَلُوش is how it's pronounced. So it's like a much more complex form as a result. And we find these online all over the place, actually. Variations in terms of the lexical aspect, how words are represented symbolically. So, if you go to tomato, in Arabic, there's about half a dozen different ways of saying that word, depending on where you're from. But also, you could have the same word that could mean different things. So this word here could actually mean a kettle that you heat in, or it could be a fridge where you make things cold. It's quite opposite in terms of the functionality. A funny thing, if you actually search for the word barad for the house, the word for house is beit, you would find this guy most of the time because he's somehow the most common barad beit, Brad Pitt in that case. And of course, diacritics may not even help necessarily in that case. So on top of this, there is a lot of spelling inconsistency that we find online, the way people write. I was the PI on a project called Qalb project that did annotation of about 2 million words of Arabic social media text that was all manually corrected, so that we have a data set, and this data set is all public right now, for learning how to do spelling correction, automatic spelling correction and grammar correction on Arabic dialects. And we found about 30% errors among the words that people write on social media, which is quite high, and it affects many other things of how these downstream systems use such text. One of the most shocking examples that I've used also, this example of this dialectal Arabic word. So if you remember from a couple of slides earlier, I mentioned dialectal Arabic has no official standards, meaning the Arab academies, like the one in Cairo, for example, or the one in Damascus, don't actually tell us exactly how to spell Arabic dialects. They just leave it to people to spell whichever way they want. And as a result, they spell whichever way they want. So you get this word, for example, that gets 27 different spellings online, or in a Zipfian distribution, so we could exploit that, obviously. But this is all basically variations where sometimes they make it write the word to match the sound, how it's pronounced, and sometimes to match the etymology or what is historically it's related to. And this is not even mentioning all what's called Arabizi, which is a Roman-based way of writing Arabic, also without any particular standard that would be also adding to this confusion and mix. So all of this stuff is fun. Thank God there is interesting problems to work with. Otherwise, I would not have a job. I would be probably working on something else. So I'm kind of happy to see this, and it's basically dedicated my life to working on this problem. And I hope I'll be able to help something, by the time I'm done in this work. So I'm going to tell you a little bit about the history, and then we'll talk about some examples of solutions that we have. So in a recent paper, I was co-author with a number of the leaders of Arabic NLP in the Arab world. This was published as part of the ACM special issue on Arabic and the Arab world. And so we mentioned that there are three basic waves that we think of as basically the history of working on Arabic and NLP. The first one was in the 1980s, kind of went all the way to about 2000. And kind of one of the most important companies at that period was called Sakhr Software. I actually, as a kid, I learned my first programming language. I learned it on Sakhr computers, and I did my first programming when I was in high school, basically using these systems. So I kind of feel, some of their books I read about it, that's kind of what they got me, interested in this area. In that period, it was mostly in these companies, very, very small number of companies, and also in some research institutes that were interested in developing data, particularly for the dialects for doing speech recognition. So some of the earliest analyzers, syntactic analyzers, etc., machine translation work was started in that period, also under companies like Sakhr and others. In the second wave, and Sakhr, by the way, was started in Kuwait and then eventually moved to Egypt, actually, after the Gulf War. But the second wave started in 2000, and primarily it was affected by 9/11 events. So there was a very big shift in the focus in terms of the amount of money that was spent on doing research and development in the world on Arabic NLP, that basically started with places like DARPA, in the US, the US Army, funding projects for translating between the dialects and standard and English, or for translating, improving translation to English of other languages. I mean, particularly it was Arabic and Chinese, of course, at the time. You can tell the particular point of view here coming into this picture. That period found a lot of collaborations between universities and industries under the DARPA funding model that supported and encouraged this kind of collaboration. And it led to creating a lot of resources that we still use today, like the Pan-Arabic Tree Bank, for example, is like the primary resource for building and evaluating morphological analysis, disambiguation, etc. for Arabic. But here, I would say, looking at it now, and I actually was part of that period. A lot of my research started in that period while I was at Columbia University. It was funded by a couple of these projects. And the focus in that period was really about Western users. For instance, we did not care, or the funders didn't care, whether you're translating well into Arabic. They wanted to translate from Arabic into English. So it's about basically serving the funder in this case, which was focused on English and basically trying to understand the Arab world and not necessarily translating to them. That's actually not completely true. Transstack was bidirectional translation in Iraqi and English, English and Iraqi, to be fair. Now, the third wave started about 2010, maybe 2010, 2012. And that was with a kind of a major shift that happened of moving toward the Arab world. So things like the Qatar Computing Research Institute starting its Arabic language technology group. People kind of, there was a lot of movement actually to, I moved in this area. Many other people moved to work on it within the Arab world itself, and as a result, you know, you get a lot of kind of Arab focus now on this, and I think it benefited heavily from the second wave, which created a lot of the basic resources and the models that allowed us to actually push forward. I think I have a question from Ling.
Yeah, that question, it's a short question just asking your ACM paper on Arabic NLP history. What is the title? Maybe you can just.
Oh yeah, I'll be happy to. I'll be happy to send the link directly afterwards. Yeah, I think it's called like a panoramic view of Arabic natural language processing, and you can find it on archive. But I'm happy to send it to you by email link afterwards if you want.
Thank you very much.
Okay. Just take a note here. All right, and in this particular period now, also one of the kind of primary workshops that have evolved as this workshop on Arabic NLP has become kind of the center where a lot of people are kind of doing work on Arabic NLP, are publishing in, and as part of that workshop, multiple competitions were run for spelling correction, dialect identification, and sentiment analysis over the last 6 years or so. And again, of course, this period had a lot of interest growing in dialects, as I mentioned earlier, because of the interest in generating the generated resources in social media. Another aspect for this wave, also it happens together with the kind of big revolution in deep learning and machine learning, and also the interest in doing a lot of open source resources that also allowed people to start working and kind of jump in quickly to work on NLP in general, but also in Arabic. Here it just kind of was just out of interest, like kind of in the last 20 years, almost the last 20 years, you can see the pattern of increase in the number of publications that mention the word NLP and also mention a particular language name published in English. And of course, English is just doing this incredible increase, but also Chinese, you know, used to be less than German. Now it's a bit higher than German in terms of the amount of work that is being done on it. And Arabic in orange and also in, I guess, light blue for the Arabic dialects have also kind of been increased, but still at a much lower level compared to these other languages. People who work on Arabic NLP are not necessarily Arabs or speak Arabic. There's actually some of the best effort have happened with people who were not speakers themselves, but who basically, you know, model the language well. So when we think kind of toward the future, and this is kind of part of the philosophy that I follow within my lab, kind of thinking of myself as starting the lab in this third wave, where we wanted to shift toward Arabic users and kind of development for Arabic primarily, open source data and tools become a very big part of what we do. Kind of, I think of this as central. Also, I'm aware of issues of intellectual property, of course, but this is kind of extremely important for us to at least push the infrastructure to make it much higher. The period in the past from 20, 30 years ago, when companies created a lot of resources and just gave you a final system, basically the moment the company goes under, this thing is just not used anymore and it just sits on a shelf. And this is something that we hope not to actually repeat in the future. Another challenge is developing shared standards so that we can actually collectively for Arabic have common ways of evaluating. For instance, you know, for part of speech tagging, there are multiple tag sets that exist in parallel that different data sets have actually recorded and created. And that's kind of unfortunate, right? Because it doesn't allow us to always be easily to compare against each other. And same with standard of spelling, etc., to evaluate the output of system, let's say like speech recognition. And obviously we have to continue following with the latest techniques and the greatest techniques. And this is the field is moving incredibly fast, but I am very proud of the community that I'm part of, in Arabic NLP, where we're catching up all the time with what's going on in other locations. And of course, most importantly is collaborating together. So just before we started, we were talking about ideas potentially of collaborating between us in universities. I hope we can follow up on that some more. And I think, the model that we know from the second wave, where DARPA did a lot of funding. DARPA is government, funded universities and companies to work together to develop systems, was a very, very successful model. It created not just a lot of resources, as in, data sets and tools, but created a lot of human resources. A whole generation of researchers in NLP in general actually started working on Arabic and Chinese at some point, if they were students of, some of the big labs that were involved in this work. And I think this kind of model is definitely something that we can pursue for the future. I think it fits very nicely with the goals of the United Arab Emirates and kind of its view of the future and importance of artificial intelligence. And I kind of highlighted and underlined the importance of creating a new generation of researchers and developers, because computer science in general struggles these days with a lot of our PhDs basically go to industry and they don't actually help produce the next generation of people. So I was very happy to hear about MBZUAI, basically trying to address this issue by helping to create this next generation of people doing this. So this is pretty much the kind of the background of where that kind of gets me to the part where I'm going to talk about my lab specifically. So the rest from here will be more specific about examples of solutions, and I hopefully will leave enough time for answers. I'm not going to be talking about any particular topic in so much detail, but I'm happy to answer any technical questions about any of the things that I will be showing you today, but just to give you a sense of what we're doing. So the lab is about almost 7 years old. We started in 2014, and when I came here, I decided that I'm going to basically focus on Arabic NLP as the only thing that I'm going to be working on, and I'm not going to work on any other language. Occasionally, I do work on other languages. If you're translating, you have to, of course. But the general interest is to create core or enabling technologies for Arabic and Arabic dialects, and to develop resources and tools. I wanted to basically have at least one goal is, at some point in time in the future, we stop saying Arabic is a low resource language, and just Arabic is just like any other language with lots of resources that can be used to develop tools and systems for it. And then we can move above the level of kind of a solid infrastructure so that we can do more interesting things, more applications, etc. And we've had quite the success so far in the last 7 years. So you can follow us on scholar.camellab for our Google Scholar, and follow us on Twitter at Camel NLP. I will just acknowledge some of the team members. So this is not all the current members, but this is the members that particularly were part of the Camel Tools group that was part of Camel Lab. So most of these people are still with us, but you could notice actually among them a couple of people who are not of Arab origin, like Alex Erdman and Go Anyway, and both of them actually are Arabic speakers. So all of the people who work in the lab are Arabic speakers of some form or another, and they help us with the development of our systems. So the website of the lab is camellab.com. You can go there and check out all of our resources and tools. Our policy is to make things all public and open, so everything is pretty much available. We ask just you register so that we have a track, and we update you whenever we have updates on our tools and resources. So I'll talk about kind of a high level of specific examples of projects, and I'll just jump right away into them. The first one is a project called Medamira. This actually, for the record, started in the second phase, the second wave, when I was at Columbia, near the end of that period, technically. And this is a system that targets the morphological disambiguation in context. Remember when I was talking about all the different ways, like the 7 different and the diacritization, the 3 core meanings, etc., out of context. So this Medamira system is a system that uses a combination of machine learning and also morphological analysis to identify the best meaning in context and the best reading in context. And this relied heavily on the existence of the Pan-Arabic tree bank to be able to train these models. The system that is publicly available, you can actually look, it's Camel Lab Abu Dhabi.NYUAD/Medamira. I'll be happy to share with Lei Song the slides afterwards, so you guys can share the slides with everybody if you want.
Thank you.
And these, so it gives you basically an input text like this, and it will give you the diacritization on that text. So it add all of the different diacritical marks. It will give you the full analysis. I'm displaying the analysis here in Arabic. The analysis can also be displayed in English for those who cannot read Arabic. And this actually works for both standard Arabic and Egyptian Arabic in the public interface. So in this example, there is no analysis for the word in green, but the moment you actually change it to dialectal Arabic, you get the analysis. Arabic speakers will immediately recognize what happened there, but just a word with a very complex morphology that does not exist in the standard language. To give you a sense of the comparison on the performance, because people often ask, why can't you just build on standard Arabic or MSA, modern standard Arabic, and then apply in Egyptian? If you do that, the quality, you'll get some results, but the quality is pretty dismal. So you're talking about a full analysis of about 27%, for example, diacritization at 32%. So these are very low results, as opposed to, of course, when you train on some of the data that we have for Egyptian, and standard Arabic, of course, has higher results because we have more data for it. We recently had some results using neural models that actually improved these numbers. So the full analysis goes from the 84% to about 92%. And we currently have results that are even higher than that are not published yet using some newer techniques. So this is kind of an ingoing problem of trying to, or ingoing sets of solutions to try to solve this problem as well as we can. And this resource, as I said, is you can download and use, and lots of people have actually used it for research in Arabic Nlp. Second project is called the Gumar Corpus. This was the first project that I actually built when I came to NYU Abu Dhabi. It is a corpus of 100 million words of Gulf Arabic. So I started here, and we couldn't find any data specifically for Gulf Arabic that we know is for Gulf Arabic specifically. And I discovered this treasure trove of documents that are all what's called internet novels, or ruwayat al-net is what they call them. And these are mostly written by women anonymously, and in forum typically. And they have, just all written in Arabic script. Dialectal forms can be, the data is incredibly rich because it could be used for building dialogue systems. It could be used for lots of other things, beside, of course, pre-trained models, etc. And what we did is we got funding from NYU Abu Dhabi to manually annotate about 200,000 words for segmentation, spelling correction, and also for tokenization. And as part of that project, we built the first morphological analyzer for Gulf Arabic. Currently, Gulf Arabic is about 89% in terms of accuracy. It's actually better than any of the other dialect results that we have in terms of its performance. The Gumar Corpus website is also there. It's linked and it's public. And a lot of linguists seem to really like using it because it gives them access to examples of text. So we have other audiences beside the AI community. Third project is the Madar project, or Multi-Arabic Dialect Applications and Resources project. And this is a project that was interested in the question of Arabic dialects and dialectal variations. And what we did is we did kind of, at the time it seemed like a crazy task. We targeted 25 cities from across the Arab world, from Rabat in Morocco to Muscat in Oman, and so many different cities in between. And we built parallel data, information for dialect identification and machine translation, and a lexicon. So we have about 100,000 sentences that are not all in parallel, but that's the collective number of them that is in parallel, and about 47,000 entries for these lexicons. This was 55 people were involved in building this from across the Arab world, and it's multiple universities. And one of the shared tasks that we had, the first ever dialect identification shared task, this was done under the workshop on Arabic NLP, was on basically, can we identify the dialect of a particular sentence just by looking at it. You can actually test the system yourself. It's called ADIDA. ADIDA is Automatic Dialect Identification for Arabic. And it's a public system also you can use. And the actual system can be used directly as an API as part of the Camel Tools effort, which I'm going to mention in a couple of slides. The accuracy of the system so far, and this in all of the competition, nobody has been able to beat those numbers, is about 68% for 7-word average sentences. And this is to select a label that is 1 out of 26 labels, so 25 Arab cities plus standard Arabic. And when you increase the signal to about 16 words, almost like the equivalent of, you know, 1 long tweet or 2 tweets together, we get closer to about 90% accuracy on that task. So that's quite a tough task. As part of this project, I just want to point out, because some of you may say, you just said the word correction a few minutes ago with Gulf Arabic. How can you talk about correction when there's no standard? Where, in fact, that was a mistake. I should have called it conventionalization. So we actually came up with a standard for how to spell every single Arab dialect that we work with. And the idea here is to basically fill a gap that the Arab academies have left open. And that is, you know, there is lots of ways of spelling these words. We decided on a way to do them. Very proud that this project, which is not exactly AI per se, but it's necessary to kind of create the standard for how to actually build the model for it, to normalize the text, etc., you know, is currently getting a lot of interest and support, even people, you know, in education. You know, there was a site for teaching dialectal Arabic that adopted this to make it something that they use. Another project that has a very different focus is SAMR project. This is a project that is still ongoing, started at NYU Abu Dhabi with people in the Arabic program, Professor Mohammed Al-Khalil, I should mention. And it's about doing simplification of masterpieces for extensive reading. So the target here was the Arab child, the young Arab readers who struggle with standard Arabic. As you remember, I mentioned standard Arabic is a very different formal language from the dialects that they grow up in. And we know people talk openly about some of the challenges, particularly in you know, Gulf countries where there is a lot of English coming into the picture, and kids would prefer to speak English and their dialect over standard Arabic or Arabic in general. And so part of the effort here is to try to take these classical effort, you know, or masterpieces of Arabic and systematically try to simplify them. Now, the task, the way it was envisioned, is as something that is AI aided, meaning that it's not artificial intelligence that will do the simplification, but it will aid simplifiers who will do this. Personally, I would love for us to get to the point where we have enough examples of data that we can actually build models that can say, oh, you don't understand what the sentence means. Let me paraphrase it for you in a readability level that is easier for you. And one of the efforts that came out of this, and this is also publicly downloadable and usable, is the thesaurus that we created basically of the most commonly used lexical entries in Arabic, also marked for their level. This is actually a very interesting space for machine learning that we're also considering playing with even further. And next to last is this effort that also is about 2 years old now, is on gender bias in Arabic. So I mentioned earlier that Arabic is morphologically rich, and one aspect of its morphological richness is that it shows the gender. So a verb or a noun must have a masculine form or a feminine form. And of course, you know, English doesn't do that, you know, for instance, and as a result, when you're translating from English to Arabic, you would have a problem. So for example, if you have sentences like I'm a doctor or I'm a nurse, the Arabic that comes out would be male doctor or female nurse using Google Translate. And that's great for people who happen to be male doctors and female nurses. It's not good for people who are not. And this comes in the whole kind of theme of people talking about bias in AI, etc. My view on this problem is that at some level, obviously, it's dependent on the data, and the data is unbalanced and biased in the world. But the biggest problem is that this is a single output system that has no access to the user information. Although Google may know our gender because we specify it somewhere, or I mean, you can figure out the gender of a person probably from enough data about them. It's a more complex question. I should be careful with that idea. Their preference for a grammatical gender, I should say, in Arabic, which has this duality that we have to use. But this is a problem. So what we did is created a corpus, the first ever parallel corpus of gender in Arabic. And I believe it's actually the first parallel corpus of gender in the world for any language. I don't think this exists for any other language right now. We had about 12,000 sentences that we collected from open subtitles, from the open subtitles corpus. We identified them manually for being one particular gender or the other for the first person speaker. So whenever there is I, me, myself, or mine in the English is when this is kind of fired. And then whenever it's a specific gender preference, we translated it to the other gender, or I should say re-inflected it to the other gender. And then we use this data to do tasks like gender identification using the textual input, and also to do gender re-inflection in a controlled way. The idea would be that a user could basically, in a post-processing process, whether it's through a system that goes on top of spelling correction or someone that goes on top of machine translation, would, through a system that is aware of the preference of the user, re-inflect so that it matches the preference of that user, right? So kind of make the user central in this process. And one of the interesting things that came out of this effort was a way to actually evaluate how good is Google Translate or how bad in terms of bias. And we found that with the balance of the intention being balanced between male and female, Google Translate picked 10 times to 1 the masculine form over the feminine form. And the feminine form was used in really, not so good context, like I am divorced, I am anxious, would always come out as feminine. Everything else would come out as masculine, as an example. And our system at the time was able to improve the quality in terms of blue score, specifically between 5 to 8% relative. And this is a still ongoing effort. I think the last part I'll mention is Camel Tools, which is this kind of big project, big vision project that is an open source Python toolkit that we developed for Arabic NLP, where we try all of the different pieces that I talked about and we worked on is basically all kind of flow into this common system. It's focused on Arabic. It's intended to be very easy to use and flexible module, all the advantages that we get with open source Pythonic style models. And we have on our, I can skip through this. You can look at the slides comparing to other sites. It's a public on GitHub, very detailed documentation. And we have also, kind of an initial guide for how to start playing with it. So for students who are interested in Arabic and NLP, I would strongly recommend, trying Camel Tools and let us know what you think. If you have any issues, issue something for us and we, put an issue on GitHub and we'll be very happy to address them as soon as we can. So I'll finish up with just a quick summary. Arabic NLP is quite a large and growing field, and it's actually seen a lot of increase in terms of quality and interest in the last few years, including opening doors to new problems. Gender bias, for example, as a particular problem was one that people, always were aware of, but have not really started seriously working on until the last 4 or 5 years in general, and definitely for Arabic, that was the case. Some of the data sets we had, for example, only translated to the masculine form, just did not translate to the feminine form. So this is something where, as we are improving the quality, we're actually opening possibilities to new opportunities of ways of working on this problem, particularly also thinking of the Arab user, in this case, as the target. And the challenges in Arabic are really, really interesting. Obviously, I'm biased here, but they open up potentially solutions for them, could actually have implications for other languages that also have complex issues of orthography, lack of standardization, and different variations. So a lot of interest. I know there's a lot of interest definitely in the UAE, in companies and research groups interested in working on this topic, and we always need more people who are interested. So if you're interested in this, let us know. We're hiring here. I know you guys are hiring in MBZUAI also. This kind of goes, among friends. Obviously, we need to get as many people to work on this. And thank you very much.
Okay, thank you very much, Professor Habash, for the talk. We already have quite a number of questions. I will just moderate the question. The first one is, what's the advantage and disadvantage of doing research in AI in Arabics?
Yeah. So when you do research in AI for language in general, you have to deal with a language. English is probably the most worked on language in the world. And as such, it's a very busy space. So perhaps one of the interesting advantages And this is, of course, this is an answer that assumes you have no other motivation. I mean, if you want to build a system that serves an Arab community, well, you're not going to develop it in English. You're going to develop it in Arabic, right? But beyond that, if you actually have the freedom of thinking about this, I think it's a very interesting space of a problem that's really complex, and as such, solutions for it can have implications for many other languages. You would be probably one of the very few people starting on a particular problem if you start working on it. And you have the opportunity, if you're an Arabic speaker, you'd have the opportunity of really working on a language that is your native language in a way that gives you potentially an advantage of that this is something that you know, and you start thinking of how do you actually make it useful for people in your community beyond itself. I can keep talking about things that are interesting about it, but maybe perhaps a person can say, I have a choice between this and that, and I can then give some advice if need be.
Okay, great, thank you. And then the next question is, what's the impact of multiglossic linguistic situation, standard Arabic dialectics and lingua franca in Arabic world on NLP? What challenges would that impose? What opportunity would provide to the field? Yeah, these are related to.
Yeah, so, and I see this is from Mira. Hi, Mira, good seeing you, or good seeing from you. You know, at some level, language in the Arab world is in a situation that is multiglossic, meaning that we have multiple forms of language kind of occurring, coexisting together. And I think at it from the point of view of a technologist that's trying to kind of serve a particular user, that we have to basically accommodate their needs. Now, I'll admit this actually to you, that there is something linguistically, and Mira is a linguistics professor, so I think maybe you should appreciate this answer. There's something kind of linguistically interesting happening, right? That we know happened in English, where Google search actually changed how people think of search, right? So now people can just think of search in a way that actually fits the machine instead of necessarily asking a question. Kind of question answering is one technique, but you know, a lot of people know how to search because they know to search for keywords. They understand the idea of it. And we can imagine over time that people develop a language that works for them, that is comfortable for them. In the Arab world, we're not there yet. So I don't have a clear imagination of if I have a robot sitting around the house helping me do stuff, how would I talk to that robot? The closest analogy, and I'm sorry if this sounds a little bit problematic what I'm going to say, the closest analogy would be, let's say if we have, you know, workers from non-Arabic speaking background, let's say in Gulf country, who evolved into like the pigeon, right? An Arabic Gulf pigeon that is a mix of, that's kind of a simplified form of Arabic. Would that work with the robots? I don't know, it may actually, right? But it's something that I think we would develop technologically. We'd want to develop systems that at least can accommodate any of these options and the user at the end. I would say we're still at the beginning of that journey. And I think we're going with the idea that we try to identify and support any of these forms if possible. So I think there's a lot of interesting opportunities for sure for studying this, and maybe even seeing like the effect. I know there's a lot of interest at UAEU of, you know, how do children learn the language? So with having robots that can speak perfect standard Arabic or Gulf Arabic, you know, help those children acquire language in a better way. I mean, there are really interesting possibilities in that direction, you know, sci-fi effectively.
Yeah, great. Great, thank you very much. Actually, like many others, including Mira, we liked your slides, which are in bilingual language. Yeah,
I'm glad.
Okay, actually, there's next question also related to this. It's since probably automatic translation is one of the early implementations of AI, where does it stand now for instance, maybe in Arabic language, and do we see any major progress in the field of AI and Arabic lexical database and online dictionary?
That's a great question. So machine translation has actually improved quite a lot in the last few years. I keep track. I have a set of sentences that are every year or so I run by Google Translate to see how they're doing. Machine translation was my dissertation area, as I may have mentioned, but I've been working more on general NLP for Arabic at this time. So I know that there's been a lot of improvement. The biggest improvement I would say in the standard Arabic quality has become really, really good for topics that have to do with news, etc. But the moment you go outside of those genres, it becomes a bit harder. In the dialects, I've seen improvements, particularly on Egyptian Arabic, that there's an improvement in the quality of the translation there. But for other dialects, this is still behind, actually. Egyptian happened to be one of the dialects that actually got a lot of attention in the second wave of Arabic NAI that I mentioned earlier. So that would explain maybe part of this. But I see if you put some Gulf Arabic sentences from the Gumar Corpus, there are many examples where things are just really badly mistranslated or analyzed. So I think there's a lot of potential there. The big problem, to be frank with this issue, is the fact, the lack of what I would call naturally occurring parallel data. What do I mean by that? So when you think, for example, of the United Nations resolutions, or the United Nations corpus that has Arabic and Chinese and English and Russian and French, that are parallel, that's a very naturally occurring corpus where people created that corpus because they're really trying to communicate with each other, right? And any of these parallel data is beautiful, but these data were created for that particular purpose. There is nothing like this for Arabic dialects. No group or institution is interested in creating parallel data for the dialects. And as a result, we're always working in a situation that is extremely low resources. To my knowledge, the Madar corpus is the only one that is multi-dialectal and has English and French associated with it. There's, of course, the data sets from the LDC that were created under DARPA for specific dialects. But I would say, if we want to really solve the problem, we have to create more parallel data and create a kind of an incentive to create such a data so that we can actually use it. Lexicons don't solve the problem always, unfortunately, because lexicons are more abstract. So you may have a lexical entry that says katab, for example, for write, but you're not going to get makatab hash or makatab lahash and all of these other inflected forms of it. So you'd have to still link them with each other.
Great, thank you. Related to that, in English, people are nowadays using lots of unlabeled corpus, doing unsupervised learning to learn some representations, using transformer and these language models. What do you think?
We love Hugging Face. So we actually just released about a month or so ago on Hugging Face our Camel BERT models with, to my knowledge, one of them Camel BERT mix is the largest to date of standard Arabic, dialectal Arabic, and classical Arabic. And we have a paper in the workshop on Arabic Nlp that I mentioned, actually showing how smart usage of these pre-trained models for about, I think, 12 different tasks we report on could actually help you if you know what the task is, like including things, I mean, maybe the Arabic speakers would appreciate this, classifying Arabic poetry rhythm patterns, like a Buhur al-Sha'r al-Arabi, to kind of automatically figure out which of the Buhur are you in. So it's like what kind of class of Arabic poetry you're in addition to things like sentiment analysis and dialect ID. So we definitely use these, and you're right, Lei Song, I mean, they actually have beaten up many of our previous systems, partly because by having all of these models kind of trained together, they end up allowing you to abstract away from some of these variations. But of course, so now the problem becomes, for my pleasure, the standard goes higher. Now we have a smaller space, a really harder problem to solve. So one interesting insight that we had found consistently, to link to what I just said to Mira earlier, is that even with the largest amount of data sets that we have and the biggest improvement that we have, in some cases, having a morphological analyzer that has kind of a model of millions and millions of forms, some of which you never see in your training, but you may see in your test, actually gives you an advantage. The advantage over the size, of course, becomes smaller and smaller, but it's definitely, for somebody starting on a new task, without a lot of data, it could be something that can help, even on top of these BERT type models. Yeah.
Actually, just zooming down a little bit into the detail.
Sure, yeah, please, absolutely.
Transformer BERT model, you need to break out the sentence into tokens. In this case,
Yes.
in Arabic language, how would you break out in the token? It looks like much more complicated than English.
No, absolutely fantastic question. And this is something that actually people have worked on. So in the Camel BERT effort that we did, we actually went with a slightly different, simple give up solution that basically was using the word piece kind of statistically based chopping of the forms of the words. And we actually wanted to model something that fit all the basic parameters from the original MBERT model to try to kind of study the differences. The paper that we published, I'm very happy about because it allows us to study from a scientific point of view, and we still got some advantage from an engineering point of view, but we wanted to study under controlled setting, what is the advantage of one decision or another. Now that said, I will answer your question, we're using someone else's work. So the group at the American University in Beirut, in the Mind Lab, who did the first BERT model in Arabic called AraBERT, in their paper, they actually do compare using a system from QCRI, the Qatar Computing Research Institute, for doing a very simple segmentation that's actually non-contextual, predeterministic kind of segmentation, but that is aware of the linguistic structure of Arabic. And they showed that if you do that before you do BPE modeling, then you actually get an advantage over doing it. We had similar results also on machine translation, that if we do kind of initial tokenization, there's lots of schemas for tokenizing Arabic. So we do a version that is not super fine-grained, but rather separate the clitics and leave the base word. It's almost like you're simplifying the spelling of Arabic into a related Arabic variant. And then you use the machine learning on top of that. In previous results from the period of statistical MT, just to kind of go back in time a little bit more, we found that if you split too much morphologically, you actually lose over time because you make your sentences longer. You have the problem of memory, and kind of remembering the connections with the pieces becomes a bigger problem. So figuring out the right sweet spot is an empirical question for the most part, I would say.
Yeah. So do you see what is the bottleneck of improving further? For instance, is it computation? For instance, lots of GPU machine, lots of corpus in order to improve it, or there are other aspects you think now is the
so I think it depends on the particular task that we're talking about. So for certain tasks that are related to, translation, I think the biggest bottleneck is data, simply at this point. I mean, I don't think, and I even with these pre-trained models, you may get some advantages, but I think that you're still kind of working in the space of, kind of slightly semi-supervised, right? When you don't have more than a few thousand examples, you really cannot really do a lot with it. In other places like morphological disambiguation or morphosyntactic processing, I think in some cases we're getting closer to potentially the limit of where we can get to. At least in standard Arabic for certain genres of standard Arabic. And so like I actually stopped publishing and kind of reporting new results, except like using really newer techniques for standard Arabic data sets, because we're in the mid-90s at this point in terms of complex analysis. But I'm kind of shifting my focus to other forms of Arabic that have limited resources, like classical Arabic or Arabic novels, because that's a space that has not really been explored enough. And I know our friends in linguistics and digital humanities would probably benefit from tools that allow them to process that kind of text and work with it. But there actually it becomes like more data. And this is, I'm not answering the question that perhaps is obvious, which is, a lot of the solutions that came with transformers are solutions that are not language specific, right? They benefit all languages on Earth, and I'm sure any improvements that happen in that direction could benefit us. I think in Arabic, there will always be the challenge of the number of forms of basic words is bigger. But this is a space that I would say we're still in the early phases of understanding, kind of so to call the art of, right? Like what is the subtleties of using these things with each other? Should there be, a cascade of processes of doing normalization explicitly that, or should it all be always joint models? Could we actually benefit better if we split the task in different ways? I'm not necessarily a person for one joint model that rules them all kind of guy. But if that happens and it does well, that's great. But there's also a big cost, as you know, for all these kind of things computationally.
Great. Yeah, thank you. Actually, our president, Professor Eric Singh, is also here.
Hi, Eric.
Yeah.
Hi, Nizar. Sorry, I didn't realize that the talk happened maybe an hour ago. I thought it's at 4, so I logged in at 4.
It's okay. It's recorded, so you'll get
so I'm going to listen to that again. Very interesting discussions already. In fact, I do have a number of technical questions, but Le already asked quite a bit. Maybe one more question I'm curious about. So with all these existing, GPT-3 models and BERT models, how do you think the design, the architecture, and also the anatomy is transferable, from English and other languages to Arab? Because I know the Arabic language is very unique, even in the reading direction, but also in many of the token structures and the subtypes of the language. So I always wonder, whether the whole thing need to be redesigned, specifically to Arab, or we can just switch to another language and use the same architecture to train the model.
Yeah, that's a really interesting question, and I'll I started working with some of these models, the BERT models, particularly with my PhD students quite recently. So I'm familiar with some of the design decisions that we had to basically, as we build the models, we had to understand all of the different decisions for them. And I can tell you, and this is something we haven't really worked on yet. We kind of stuck at this stage of following the definition that is done for the languages, like for English, etc. But like one of the insights, for example, that came out is, there is, this distinction that happens when you do the tokenization of the basic word, like in word pieces, for example, where you have always the form of the word that is, let's say from an English kind of point of view, is the base, and then you have the continuation, the hash something forms. And sometimes you just simply, the model would produce the probability on the head, the first item in the series, and then decide this is really what you want. The thing is, that kind of model is biased because it's thinking of languages that are what we would call head initial languages. So languages that actually, the base at the beginning and then things follow. Interestingly, Arabic happens to be a head initial language, linguistically speaking, but not orthographically. Oddly, orthographically, the way it's written, there are multiple things that attach to it that come from before the form, before, and then things that happen after. And one of the most common one, just to kind of get you the sense of why this was surprising to me working on it, was the conjunction and. The word wa means and it's used a lot. Better than commas, beginning of sentences, etc. But then that by default becomes the first item that you kind of assign the main probability for. And that's a problem, obviously. So I've actually talked with my students about thinking of, can we actually change the way we model this? So we would have to identify a different point as the most important point, or figure out a way where we can share this somehow in some way. This is the first thing that comes to mind. And I say I am a student of that technique still, and I'm learning how to actually take what I know and work with it. But definitely, I'm sure there are lots of issues that could be improved that way too.
Okay, that's great. We have a couple of faculty and students here interested in reinvestigating, the language modeling part.
Excellent.
Maybe we can collaborate and discuss.
I would be very happy to do so. Actually, yeah, please.
One problem, of course, with the GPT-3 model is too big. It's very, very hard to even experiment that, or or manipulate or augment it. So yeah. I'm wondering whether we should start from the scratch and design a smaller kind of version, or we piggyback on top of that and try to unlock the G42 kind of a computer farm and do bigger experiments. So anyway, I love to.
I think this is a really interesting question. I will send you a link to a couple of papers on this for stuff that we had worked on. So we found out, at least with the work that we did on the Camel BERT effort, that after a certain large size, the advantage actually is not consistent. So we're kind of plateauing as we go to the higher numbers, which means potentially as we develop from a scientific point of view, we're developing lots and lots of experiments. It probably may not make a lot of sense to kind of try them on the higher end, but rather on something initially at the lower end to see if we actually can do well. And lower end is still huge, you know, in comparison to a few years ago, of course.
Yeah, exactly.
But I think that's definitely something that we saw. We also saw that like a classical Arabic model that we built, a Camel classical Arabic, and I believe this may have been 1/16 the size of the standard Arabic model, but it did better in things that have to do with classical Arabic, and better than when you mix everything together. So, and that may be an interesting modeling space. I mean, the first question comes to mind, can you add another tag that marks what the source of the sentence is so the model can learn jointly, you know, the dialect type ID, etc., or genre together with the model itself, right? So that's a really interesting possible space that could be explored. That would be like within next steps. So we should have a kind of a brainstorming session and talk about ideas. I would love
absolutely
to.
Yeah, I'd love to have you on campus, or at least begin by reading the papers you mentioned. And
absolutely.
By the way, I don't want to hijack the conversation. I know there are some questions out there.
Right. We have already gone through lots of
Sure.
Yeah, we've already gone through lots of the major questions, and we are over time. Yeah. Obviously,
I'm happy to keep answering questions. Not a problem.
So there are some smaller questions, maybe something like, how do Arabic chatbot handle gender endings, or is there a gender neutral conversation?
Oh God, yeah, that's a really interesting question. I will relate this to one of the questions that says, what does gender B means? Because the two are connected to each other, actually. So Arabic inflects for gender, but there are lots of constructions that are actually gender neutral, meaning if a person said it, you cannot tell their gender. And so whenever it says gender B, this would be the form where if somebody says, you know, something like, you know, I want a Diet Coke, in Arabic, that you cannot tell if it's a man or a woman is speaking. But if you say I am happy, then you can tell if it's a man or a woman, because of the ending will shift between the two. So I worked on a simple system with a student, an undergraduate student a few years back, called Batta, and it's the first Egyptian Arabic bot. It was very classical method, like, you know, the AI ML kind of in the olden days. But in it, we actually had to play with this question: can you actually do something that is gender neutral? And it's really tough, you know. So there are certain things that you can kind of, you know, what's the word, like, you know, circular kind of go around the way of saying answers or asking questions that can allow you to hide that you don't know. For example, I'll just switch to Arabic for a second. So if you want to ask somebody their name, you can say, you know, ma usmuka or ma usmuki, or ish ismak, ish ismik. And that tells you the male versus the female. But you can also ask al-usm al-karim, which means like your honorable name, the honorable name, which then you don't have to actually specify, you know, what the gender is of the person. This actually is an interesting topic that also is within the whole area of NLP and AI, now being very aware of gender bias in general, but also bias against, you know, genders in the gender continuum that are not necessarily male or female, that are in between, or other, or non-determined, you know, non-binary genders, I think is the proper term, that we actually think in Arabic, how would you actually solve such a problem for that particular community? There are actually communities interested in this online, not very large, but I think there are ways we can do around it, but I've talked with one of my students at one point about the idea of, can we actually generate guidelines to actually say, can I generate a way of saying anything that doesn't tell the gender of the speaker as an exercise? And I think from few examples, I found it quite hard. I think I need people who are maybe really good and imaginative using the Arabic language to help us with just that. But really interesting question, I have to say. Yeah.
Great. I think we have covered almost all questions. The last question is also really transformer, the pre-trained model. With that, I would like to thank Professor Habash again for the wonderful talk and this nice discussion session. Hopefully, we can meet again, right, for research discussion and exploring potential collaborations.
Absolutely. Thank you all. Thank you so much, Lisang and Eric and MBZUAI for hosting me. I look forward to meeting you in person. We are back on campus here, and I can see that you are back on campus. And perhaps we can start exploring actual in-person meetings.
Yeah, let's do some in-person meeting.
Absolutely, absolutely.
Yeah. Can you shoot me an email that we can actually get connected on emails and then plan?
Absolutely. I will fire out the emails and I'll send the links that I mentioned. I will also send Lisang the slides so he can share them with the audience. All right. Good seeing you all. Thank you, everybody.
Thank you, everybody.